But I want to remind everyone that we have this basic probability of an event. Let's call the event E or whatever. We're going to represent that with P for probability and then the event description or name in brackets. That's simply going to be the number of outcomes that satisfy that restriction versus, in the bottom, the total number of outcomes without any additional restriction. Now, some places in the book, because the universal set is also called the sample space, some books and some places in this book, you might see an S, but they are exactly the same. It's really a matter of, are you coming at it from a mathematical side or a statistics side? They mean the same thing either way. So that's what we did yesterday, I believe. Now, let's look at an example, and I'm updating 6.1 to something I think a little bit more clear and simple. Let's suppose I have a class or a group. There's a group of people, and we can look at two properties for any person. Let's suppose they're either male or female. Simple properties. And let's suppose we have another property. Let's say some have a calculator and some don't have a calculator. And let's say we have some people like that. And let's put some numbers in here. We also, so let's suppose we have, no, it doesn't really matter, does it? Let's say we have 15 males with a calculator. Let's say we have 35 males that don't have a calculator. And then we can have a total column here. That might help us. And that's going to be, oh, I don't want 50. Backtrack. Back it up. Let's change the 15 to 5. So that we have 40 males in total. And let's pick some other numbers here. Let's make this 20 females with a calculator and maybe 10 without, giving me 30 in total. And we can also have totals for the rows. I have 25 people with a calculator. I have 45 people without a calculator. One way or another, the total number of people is 70. Let's suppose we have that breakdown of the people. So we have 70 people, and every person is going to fall somewhere in that grid. All right? So now we can ask questions like the probability of having a calculator. So let me just, I need to backtrack, sorry. I'm getting ahead of myself, so excited. I just need to be aware of what the experiment is that I'm doing and what an outcome is, things that I'm counting. To keep it simple, I'm selecting one person, and it's going to be random selection, so that every person is equally likely to be selected. I need that to be able to do probabilities in this simple way. It requires that every outcome is equally likely. So I'm just selecting one person from this group, and then I can ask different things like, does the person have a calculator? So the probability of having a calculator is going to be a fraction, the number of people that satisfy that restriction, over all the people with no restriction. Well, there are 70 people, so the 70 has to go in the bottom. And now I look at my table, how many people satisfy that having a calculator requirement? 25. So because the table is completely filled in, it's as simple as just picking the right numbers. Okay, that's good. Everyone with me so far? Nothing too bad. Basic probability. Let's have some more here. Let's ask the probability of being female and having a calculator. Zoom out a little bit so I can see the table. That's still a matter of selecting a person out of all possible 70. But now my requirement, or my restriction rather, telling me which people I'm interested in, has two parts. It needs to be female and the person has to have a calculator. So that is the overlap. This is really an intersection. Female and having a calculator, which will only be this 20 over here. So 20 out of 70.
Do you want the percentages after those or no?
I sometimes like percentages just because they are a little more intuitive to see if something's likely or not and how much, but it's totally up to you. I don't care. I just do it sometimes out of curiosity. What is 20 out of 70? And then I can see, ooh, 28%, it's okay. It's not very likely. But it's totally optional. The issue is that I might have a combination of properties in giving me my restriction. I still just look at the table and combine them. And I can ask many other things, a bunch of things. This is just two examples of them. But then I can ask more interesting / complicated kinds of probability questions. I'll write it in words first. Given that the selected person is, let's say, has a calculator, what is the probability that they are female? So because I'm changing exercise 6.1, I have to write the questions again, unfortunately, but that's okay. Now this question isn't like the previous ones. I imagine someone going in and selecting the person. Sure, it's random. They select the person, they take note of their male-female calculator properties, and then they come out. I'm waiting outside. They come out and they tell me, I selected a person that has a calculator. That changes my probability question. Because right away, I don't have to look at people, I don't have to consider people that don't have a calculator. It's now a given information, a fact that the select person has a calculator. So it's only going to be out of those people that have a calculator. Because it's given extra new information that I can use. Then, out of those people, what is the probability that the person is female? 20 of those people. I never have to look at the not having calculator people, because the person that made the selection came out and said, I selected a calculator person. That reduces the total options. Yes, it's no restriction after the given information is used. That I'm only looking at the 25 people that could possibly have been selected. Out of those, only 20 are female. So we have this different kind of probability. It's not a normal probability like before. I'll call these normal, struggling to write, normal or basic probabilities. Straightforward, counting. This one is, so these ones. This one is called a conditional probability. There is some extra condition, some extra information that I know, which affects the chances of getting what I'm interested in. It changes that bottom number. It's not 70 anymore, because I incorporate that extra information, and it changes the chances of getting the person, the event, the restriction that I'm looking at. Many thoughts so far. It changes the situation. So we can write this. Oopsie, where's my hand? I can write this as in a shorter way with the P. The first part is still the probability of what? In this case, female. Then I need to keep track of what was this given new information. So I'll put a longish line there, and then write down the given information, which is having a calculator. So that's how we're going to write a conditional probability. Because I need to know these things. What am I interested in? But what is given? Is there anything given? Yes, having a calculator is now a fact. And that does change things a little bit. And I can, of course, ask other things. For example, we can have more here. I have this shorter way of writing it. What's the probability of a person having a calculator given that they're male? Or let's say not having a calculator. Let's make it different. Well, I go to my table either way. I identify, okay, this is a conditional probability. Given they're male, I'm now restricting myself just to that because it's a fact. The person's not tricking me or anything. The given information tells me I'm only looking in this male column, so it's out of 40. Not having a calculator, 35 of those. I don't think I can zoom out to see the table. I guess I could. All right. Any questions on this newish conditional probability concept? Yes.
So if you use the 40 for the one that we just did, wouldn't you have used 30 for the
given information in the second one, this one, was different.
Oh, okay.
Given the person has a calculator, that was the restriction, not the restriction, that was the sort of reduction of the whole pool of people. It was according to having a calculator, which limited me, because it was written as a row, to that first row. In the second one, the given information, the given fact is that they're male, which restricts me to the males, which happens to be a column. So it's a matter of what information is given and how does that reduce my pool of people I still need to consider. Any other questions?
So the given's always written after that long?
Always after, yes. And I mean, I could, of course, I could have written this out in words, it's just the shorter way. So that line technically means given. And usually, actually always, that comes after. Even though in a worded question, it could be first, it could be last. In my probability representation, the given information is last. I see where you're confused, yes. I'm writing it in this way always. Given is always the second part after the line, even though the words could be flipped around and anything. That's what makes word problems so tricky. It could be so many different ways of saying something in words, but mathematically we have a specific way of saying it so that it avoids confusion. We just have to be able to read the parts to that probability question. Any other thoughts so far? All right. Now, this is still fairly straightforward because we have all the numbers available in the table. In some situations, we won't have all the numbers, and the situation might be a little different, and we don't have a nice table to extract the numbers and make the fraction. The conditional probability can be a little complicated in those situations, but there is a way to make it simpler. Let me just zoom in here for a new page. In some case, right now, because we have the table, it's going to seem a little unnecessary, but soon it won't be. We can rewrite a conditional probability or probability in the following way. Now, it's explained in more detail in the book, but I don't think that we need the detail. We'll just verify it with our table example. If I have two parts in a conditional probability, could be calculator, female, whatever, just two things. This F doesn't mean female. I can rewrite that to normal probabilities, but the downside is it's going to be two of them in a fraction. The top one is going to be a normal probability where I take the intersection requiring both of those. Not a conditional probability, I just combine them in this way. And the bottom one, the second one, is going to be a normal probability of just the given information. So let's just use now it seems as if that formula is very made up. I can totally explain and defend it, but I don't think it's going to help us understand anything better. It's more a question of using it. So let's use this in the previous example to rewrite this bottom probability, which is a conditional probability, and see how we could have gotten 20 out of 25 in another way, as if we didn't have the table in this nice format. So our conditional probability is female given having a calculator. So let's verify with the previous example. So our probability was having a calculator. No, what was it? No. Female having a calculator. Whoops, sorry. Female given they have a calculator. Let's use, instead of doing it directly, which sometimes we're not going to be able to, let's use a formula which creates a fraction of two normal probabilities. The top one is the intersection of the two, and the bottom one is the probability of just the given information, as if it's not given, just a general normal probability. So I'm changing what I need to find, and it turns out that these individual probabilities, even though I have two of them, they're going to be easier to obtain usually. So the top one requires that I'm looking at all 70 people because it's a normal probability. And I need to pick people that are female and have a calculator. So looking at the table, that's going to be female and calculator. 20. It's going to be the 20. 20. Now I have to flip back and forth, but you have the table in front of you. Is everyone happy with the 20 out of 70? Because it's a normal probability, I know nothing else that can allow me to reduce the pool of people. So it's out of 70. But there are only 20 that are female and have a calculator. How do we feel about that so far? Normal probability. The bottom one, I just do this as if there's nothing else. That's all I'm looking for right now. The probability, normal, of a person having a calculator. Well, that's out of 70 because it's a normal probability. Nothing's given in this little probability question. People having calculators will be 25. 25. Right? Because that's the only requirement I need to meet, 25. And then when you calculate that, you'll see it is the same as this. It's the same. But right now it might feel, well, we could have gotten the 20 out of 25. We didn't need this formula. Soon we won't be able to get it directly in some cases. The formula is going to make things much easier. I want to notice, yes.
How is 20, like the top part of fraction in the formula is 20 over 70.
Yes.
How does that translate into just 20 on the...
If you plug it into your calculator, or if you remember fractions well, division by a fraction is multiplication by the reciprocal, and then the common factors cancel, and I get the original.
So,
or you can just use your calculator and verify that
so but
two
would
ways.
that be 20 divided by 70 to get the top number?
20 divided by 70 divided by, in brackets, 20 divided by 25 divided by 70. Yeah, just use brackets. So you can put, maybe for safety, in terms of using a calculator, you can put brackets like that. Yeah. Regardless how you verify it, the formula is correct.
Please remember to click the like button if you enjoyed the video and to subscribe if you want to be notified of more videos. Thank you.